Hello, algebra students. Well, we're going to do an application of quadratic equations. We're going to do a right triangle problem. And here's the problem. A right triangle has one leg that's 3 feet longer than the other. If the hypotenuse is 11 feet long, how long are the other legs? So let's start by drawing a picture. Anything that has geometry involved usually is good for making a picture. Here's a right triangle. It's a right triangle because one of the angles is 90 degrees. And the side opposite the right angle is the hypotenuse. And I'm going to label that as 11 feet because that's what we're told the hypotenuse is. The sides that are adjacent or next to the right angle are the legs. And we're told that one leg is 3 feet longer than the other. So just looking at this picture, I see that the bottom leg looks a little longer than this vertical one. So if we name the vertical leg x, in algebra, if we don't know the size of something, the amount of something, we'd give it a variable name, right, like x. And the other leg is 3 bigger than that other leg, so it should be x plus 3. All right, now what are we going to do? We have to dig deep into our geometry knowledge to the Pythagorean theorem. And I think most of you will remember the Pythagorean theorem. Usually the triangle is labeled with the legs A and B, and the hypotenuse is C. And Pythagoras says A squared plus B squared equals C squared. The sum of the squares of the legs equals the square of the hypotenuse. Okay, so how are we going to apply that to our problem? Just looking at these two triangles, it looks like our x is like the A, the x plus 3 is like the B, and the 11, the hypotenuse is C. Okay, so let's apply this Pythagorean theorem business to this. So we're going to get x squared plus, and then b is this binomial, x plus 3. I'm putting it in parentheses because we got to square the whole thing. And that's going to equal the c squared, which here is 11. So 11 squared. All right. This is an equation with one variable, so hopefully we can solve for x. But, I mean, it sort of looks quadratic. I guess when we multiply out this binomial, we'll get an x squared. So it's got an x squared in it and some other stuff. Let's see if it really matches a standard form quadratic, which, if you remember, was something like ax squared plus bx plus c equals 0. That's the general form. So does this have that form? Let's find out. Let's multiply it out. So we get x squared, and then if you multiply out this binomial, you could FOIL this, but I've done this so many times that I know we're going to get this. I've done a lot of factoring in my life, right? So that's how I know that this is the trinomial you get when you square this. You could FOIL it on the side. All right. And that's going to equal 11 squared, which is 121. All right. So I see like terms on the left. We've got an x squared plus an x squared. That's 2x squared plus 6x plus the 9 equals 121. This general form has a 0 on the right, so let's take away 121 from both sides. And then we'll have this thing in general form. 2x squared plus 6x, and what do you get when you take 9 and subtract 121? I think you get negative 112. Right side 0. Well, I see that we've got coefficients on the left, the a, b, and c. They're all divisible by 2. It would be nice to divide both sides by 2 and make this even simpler to work with. So I'm going to divide everything by 2. That means I could divide every term on the left by 2 and thing on the right, the 0 by 2. And what do you get when you do all these divisions? You end up with x squared plus 3x minus 56 equals 0. All right, so looking at this, can you see that the A is 1 and the B is 3 and the C is negative 56? I've used capital letters so they don't match the little letters I used for the triangle before. But anyway, so how can we solve this? Usually, well, first let's write down that this is quadratic. If you can factor this, then it's easy to solve for x. We'd have to find two numbers that add to 3 and multiply to negative 56, but I don't think you're going to find any integers that do that. So this is prime over the integers. But let's use the quadratic formula, right? We could use that for any quadratic. Certainly want to use it here since it's prime. Okay, it's prime over the integers. It's not prime over the real numbers, as we'll see. Okay, so the quadratic formula, you should have this memorized by now. X is going to equal negative b, so negative 3 plus or minus the square root of b squared, so 3 squared, minus 4 times the a, which is 1, times the c, which is negative 56. And that's all divided by 2a, so 2 times 1. And let's simplify what's under that radical. It's really going to be 9 plus, well, 4 times 56 is 224. I'm adding it because when you multiply, you get a negative, and you're subtracting a negative, so it's adding. And if you add 9 and 224, you get 233. So we finally get that x equals negative 3 plus or minus the square root of 233 divided by 2. Now this is actually two numbers here. Let's write them separately so we can see each one. We'd have negative 3 minus the square root of 233 divided by 2, and then the other one would be the addition of those terms on top. All right. So we're looking for a length of the side of a triangle, so a negative number isn't going to work, right? So I'm going to toss this one out. Negative 3 minus square root of 233, that's negative, divided by a positive, that's negative. So we're going to toss this out. Toss out because length is not negative. That leaves this other quantity as our answer. The leg that we labeled as x is negative 3 plus the square root of 233 divided by 2, and the units were feet. So that's the exact length of that one leg. Now, the other leg was 3 longer. So let's just add 3 to this x and see what we get. So I'm just copying what x is, and I'm going to add 3. Now the left side, this left term is a fraction. We need to write fractions with common denominators. What's 3? That's going to be 6 over 2. So now we have a common denominator. And if we add up the quantities in the numerator, we're going to get 3 plus square root of 233 over 2 feet. So this is the length of the other leg. This is the longer one. If you put this in a calculator and get an approximation, it's kind of nice. You get 6.13 for this one, the first one, the x. And we could put this complicated business into a calculator and get another number, but can you see that 6.13 plus 3, right, it's 3 longer, is simply 9.13. Put the units on their feet. So that's the approximate size of those legs. And we would like to check our answer. And we would use the, the a squared plus b squared equals c squared from before. But that's these quantities, and squaring those is going to be messy and everything. So let's use the approximations and see if we're super close. So remember, this is like the A and this is like the B here. So 6.13 squared plus 9.13 squared. I put that in a calculator and I got about 120.93. What's it supposed to be? Well, when we squared 11, we got 121. So we're supposed to be close to 121. And that is close to 121, right? Very close. So I would say, yeah, it's working. In fact, if we kept more decimal places for these approximations and squared those and added them together, we'd be even closer to 121. All right, everybody. Hope you enjoyed that problem. We'll see you later.